Welcome to Tech Leaders Today with your host, Cassie Crossley. All comments, views, and opinions expressed on this show are strictly those of the host, guests, and callers. Now here's Cassie Crossley.
Hello and welcome to Tech Leaders Today. I'm here with Steve Aukstakalnis. He is a research scientist, instructor, and three-time author in the field of virtual and augmented reality. He has spent over 2 decades working with academia, government, and industry in the application of these technologies in such varied areas as architecture, national defense, and medicine. Welcome, Steve.
Thank you very much for the invitation.
I am very interested to talk to you today about your book, Practical Augmented Reality, a guide to the technologies, applications, and human factors for AR and VR. Can you give folks a brief background of who you are and why you wrote this book?
My first exposure to virtual reality came in late 1989, and I was wandering around the campus of the University of Washington and stuck my head into a door, just seeing what was going on in different places. And they were working with these technologies. You start hanging around a little bit, and eventually somebody says, here, sweep the floor, do this. And this was kind of my bottom floor entry into the field. Following that, I joined the research faculty at the University of Washington for a few years, then went on to join the faculty at Mississippi State University, where I had a joint appointment with the National Science Foundation to direct a large virtual reality research program at one of their engineering research facilities. Sprinkled into this time, there have been 3 books that have come out. I've done research and lectured on this at over a dozen universities around the world, and for most of the defense component to our government, as well as the intelligence agencies, helping them meet their varied information display needs. And this is where we are today.
And the book itself, you've written a few other books, but why did you feel the need to work on the augmented reality topic?
When I first started writing about this field, the first 2 books exclusively covered virtual reality. And the reason being is that that was just the dominant technologies that were available at that time. In the last few years, augmented reality has grown in popularity as the enabling technologies have allowed commercial products to hit the market. And the close relationship between the 2 visualization tools, I thought, necessitated another book that would add some clarity to the underlying science behind these new field that's absolutely taking the entertainment field by storm, but nobody really has an understanding of why it works the way it does. And that circles back to our perceptual mechanisms, how the eyes work, how the ears work, how your hands work, and being able to detect different textures and so on. And I approached the publisher. They thought it was a great idea. And 16 months later, here we are.
I thought the book was really interesting because you covered more than just the technology portion. You did cover that biology and how we need to understand both the visual, the auditory, and even the tactile for the usage of augmented reality. I even moved to the back of the book just to understand, because you had a topic about why people get certain sicknesses, because I do not do a lot of virtual reality items because of motion sickness, or as I found out, there's 2 different types. But talking about this book itself, you cover the biology and the technology, so it's good for a student in computer science and other fields to really understand the entire scope of augmented reality. And that's what impressed me a lot about this book. Is that what you intended it for?
Absolutely. In order to properly understand how these displays function, the head-mounted displays, it's important that people understand the mechanics of human sight. The same thing holds true if you want to understand binaural 3-dimensional sound. It really is important that you understand how we hear, the mechanics of our sense of hearing. And then for tactile and force feedback devices, understanding how the mechanoreceptors in your fingers allow you to distinguish different textures directly ties into the design of tactile and force feedback devices. And that if you understand the physiology, then you understand how to design the mechanical means of addressing that sensor. And so, yes, it was very much intentional to try and make people's understanding human-centered as opposed to technology-centered, in that the overall goal of these technologies, instead of making the human more computer-like, you want to make the computer more human-like in the way that it displays information to you. By making human physiology a key part of the book, people get that understanding of why the displays are designed the way that they are.
Yeah, that's always very interesting to me because even as you talk in the beginning about binocular and the different types of vision, I personally have wondered how are people going to adapt because we all have different eyesight and you go into really understanding that because it's not just looking at a computer screen every day. I think that we'll find that will be the difference between augmented reality and even virtual reality done well or done poorly. Is if people understand the mechanics behind it and why it is successful, then that will make a big difference in the future.
It also goes directly to creating the content. The simulations are what's nicknamed the Sims. If you understand the mechanics of human sight, it also gives you tremendous insight as to how to design the 3D models. For instance, if you understand the 15 basic depth cues that have been identified as being used by the human brain to be able to perceive depth in your real world surroundings, then you can apply those same types of depth cues into the 3D models or the simulations that you're creating in order to make the visual sensation of immersion into those images far more compelling.
This book is essentially a course on augmented reality. Do you find that the people coming into the field know this information, or is this the one-stop shop where they can walk through it and really be able to, I don't want to use the word augment as a pun, but augment their current technology skills to move into AR or VR?
Oh, absolutely. The human body is outfitted with a set of extraordinary sensors. We have 2 eyes, 2 ears, our hands. Humans are spatial beings. We see, hear, touch, and move through our surroundings in 3 dimensions. And understanding that process of how we perceive our real world is directly relevant to how we understand and perceive these 3D computer-generated models that people are experiencing in these virtual environments.
How do we find people who have this background to be able to work on AR projects? Let's take the audience of this podcast are generally mid to large companies. Nobody has a decade of experience in AR unless they've probably worked in a government facility. How do we grow or attract or bring on these new functions into our corporations?
One of the primary avenues for entry into this field, clearly a background in computer science and programming, but more so having experience in 3D modeling. So using simulation engines, for instance, like Unity, or learning CATIA or Delmia or Unigraphics, AutoCAD even. Learning how to design things in 3 dimensions using any of the available CAD packages or modeling packages. That's big business right now. The people that have that skill set are in great demand in this field. Knowing how to program effectively is also an important position. And there's no 2 simulation needs that are identical, and being able to go in and tweak code on the fly, so on, when you're dealing with a client and all that, these are particularly valuable skill sets in this field. To be completely honest with you, the sky's the limit with anybody entering into this field. I would think that probably worldwide there's less than 500 people that have a super deep understanding of these technologies.
With the 3D modeling and the programming skills, with the technology moving so rapidly, they just need to have the background to learn new technologies. Just in the middle of the book, you talk about the different displays. Those displays must be changing every few months. How do you keep up with all of this?
Well, the wonderful thing about the rapid growth of the display market is that at the current time, a vast majority of the displays all use the same technologies. So they're using a flat panel array, one in front of each eye, stereoscopic wide-angle optics to spread the images to cover most of your horizontal and vertical fields of view. Most of the systems also use some type of accelerometer or other means of tracking the position and orientation of the user's head so the computer knows where you're looking, so it knows what images to draw. So if you, for instance, are walking towards a virtual building and you walk in through that virtual door, you can physically stop and turn around and see the door that you just came through. And to be able to do that, the system needs to know where you're looking. All of these technologies together, you can essentially find them in every version of the head-mounted displays that are out now. But there are the next generation of displays that are currently being developed are going to be dramatically reduced in size and weight, because they will, instead of displaying imagery in front of each eye, they will project imagery into the eye and use the retina as the display surface. And so by removing the display elements from in front of the eyes, you then can remove a vast majority of the optics. And it's those two components and their subassemblies which give it that large form factor. I would think that within the next 2 to 3 years, you'll start to see displays that are coming out that you cannot differentiate from a pair of Bolle sunglasses.
That's amazing. You're going to have to be revising this book every few months with all of those changes coming out.
In the latter chapters of the book, we do point towards where the display technologies are headed. Some are even moving completely away, and they are adding the optics onto a contact lens. They are currently in FDA trials, and it has a small little optical element that's about 0.5 millimeter in size that's right smack in the center of the contact lens. These are normal prescription lenses, dual use, so that even if you're not using the virtual reality stuff, you can still wear these as corrective lenses, but it'll allow you to dramatically reduce the size of the overall display that you actually have to wear. So these are being demoed right now at tech conferences like CES.
These are straight out of the sci-fi movies. Is there anything that they have not started to develop that you think is going to progress from a technology standpoint?
Absolutely. Head-mounted displays for the visual side are definitely advancing rather quickly. The integration of binaural three-dimensional sound into these simulations as well is also moving at breathtaking speed. It's already to the point where you can take a CAD model that you've created in, for instance, AutoCAD, and you can specify materials for the walls and the interior of the model. And then you can actually simulate the acoustics of that virtual closed space by taking into account the sound absorption coefficients of the different building materials that you specified. Now that's so that you are able to determine months before you even start turning dirt in a construction process. You can visually experience the interior spaces. You can acoustically experience the interior spaces with a considerable amount of accuracy. And the tactile feedback side. So right now, inside of these different gloves or the different controllers that you would use to maneuver your viewpoint through these 3D models, there's a group in Spain that has developed a suit that you can put on that has small contact points. I don't want to use the word electrode, but what it does is it imparts a small electrical impulse at about 50 different places to your skin, and it simulates the nerve signals that are sent by the different mechanoreceptors that allow you to feel textures and pressure on the outside and so on. And so I think we're going to be moving in the next few years away from what are technically referred to as vibrotactile displays to gloves that you put on that will just impart small electrical impulses to the fingers. And in the testing of this, they can already simulate, let's say that you've got your head-mounted display on and you're looking at a virtual butterfly, and you stick your hand up. The current accuracy of the system is that it will allow you to actually feel a butterfly fluttering in the palm of your hand or feel rain falling on your palms. There's challenges in the industry that how much money do you want to invest into these different technologies when there's not a firmly established customer base as of yet? Because everything's so new, content developers are waiting for the hardware developers and so on. And large companies like Intel and Facebook are trying to jumpstart the industry on both sides, where they're funding content developers as well as funding hardware developers so that both sides of the industry come out at the same time so you can have excellent displays and excellent content as well.
With the discussion on tactile, I mean, it seems like all we're missing is smell. I mean, you have pretty much almost all of the senses then.
Well, actually, the smell side, depending upon the application, smell can already be added to this. As an example, The Institute for Creative Technologies at the University of Southern California has developed a virtual reality system that is used at over 50 VA medical centers around the country to treat post-traumatic stress disorder. And so they have virtual Iraq and virtual Afghanistan, where the patient will come in, stand on a platform, put on a head-mounted display. There's bass speakers inside of the platform that they're standing on. So when there's, for instance, an explosion, you have the tactile sensation of the floor rumbling. You can see the particular simulation that you're in. It's like, a little Afghan village, or you're on a bridge crossing a river or something like that. And what they try to do is simulate the triggers that bring on the anxiety attacks. Part of this whole system is they have a little machine that has little liquid containers filled with the scents of burning rubber, diesel fuel, the smell of gunpowder being fired off, trash. And in addition to the visual side, or the visual simulation that they're giving to the patient, as well as the three-dimensional sound and the tactile side from the vibrations coming through the floor, they also will introduce the smells to them as well with little fans. It's a very compelling simulation that you're in. And they're finding in the VA medical centers that this is having a profound impact, in that you don't have to go and visit remote locations with a therapist and a patient in order to be able to start to address some of the problems. They can do it within the safety of the clinician's office. And this exposure therapy is also now being used to treat fear of heights, fear of flying, fear of storms, anacrophobia, and so on, just by gauging the amount of exposure the patient is subjected to and allowing them to deal with the ramifications of that.
That is just astounding where it's going. You mentioned already several different applications, several different commercial usages, and in the book you cover quite a bit more. What do you see as some of your favorite potential commercial application of AR?
For augmented reality, the enterprise applications for these technologies are profound. I'll use them as an example, an Amazon warehouse, where you have an army of individuals that are racing up and down the aisles, picking to fulfill orders. If you were to have a head-mounted display that, for instance, provided directions on maneuvering through the warehouse, an onboard camera that would scan the labels as soon as you pick an item out of a bin, instead of using a handheld scanner to scan it, you just hold it up and look at it, and it automatically scans. Put it inside of the basket, move on to the next one. If you're saving 15 to 20 seconds per picking task over the course of an entire shift, you're actually saving tremendous amount of time, which in turn allows you to fulfill more orders. Providing useful information inside of an environment like that to help somebody become more efficient on their job through an additional information display. Companies around the world are recognizing the value of this. The U.S. military is preparing to deploy augmented reality displays in what they refer to as dismounted soldier applications. So it's a single-eyed system, a little monocle flips down in front of one of the soldier's eyes. On that surface, they're able to visualize, for instance, aerial photos that are taken from a UAV, tactical maps that they've been provided. They're able to see the positions of each of their teammates, even if hidden behind a structure or behind the side of a hill. An additional information display that provides the soldiers an increased level of situational awareness. That's another favorite of mine. And then the third, starting in 2020, every aircraft that flies in U.S. airspace is supposed to have what's called an ADS-B transmitter. And this is a transmitter on the aircraft that just broadcasts out your basic avionics information. There's another side to the system that you can purchase if you want, which is an ADS-B receiver. So you're able to suck in all of this information being broadcast by all of the other aircraft. There's a company, I believe it's in Belarus, that's working with Embry-Riddle University in Florida to make an augmented reality display that will take this data, this ADS-B data that your sensors are sucking in, and they're able to display it as a graphic representation. And so you're able to see the flight pathways. You're able to see icons representing other aircraft that are flying around you, showing their speed and their heading. you're able to draw restricted airspace as semi-transparent cylinders. So if you want to stay out of the restricted airspace, don't fly into the colored area. And all of this will be available within the next, I would say, 18 months for private pilots at under $1,000 a piece. So those are the three that really have piqued my interest.
I also saw in the book a picture of that monocle type of device by surgeons. So you think in healthcare also the use of augmented reality will be a big game changer?
Yes, absolutely. As a matter of fact, it already is. Many hospitals, and in particular university hospitals, are using Google Glass or similar types of devices as a way to not have to carry around patient records. Inside of a hospital, normally a physician will come in, meet with you, then they go outside and they flip open the book that's in the little wall holder, take down notes and so on. They have to call somebody to get the x-rays delivered and so on. Well, with these types of systems, you're able to access the hospital telemetry. When you walk into a patient's room, it automatically will display vital signs, even while you're still looking at the face of the patient. You can call up with verbal commands and bring up different medical imagery like MRIs and x-rays and so on, or just bring up the textual version of the patient's chart. They're finding this makes doing rounds far more efficient. We're able to process more patients through in a given amount of time because you're reducing the overall workload of the doctors.
That's incredible. With the consumer side, they're also putting AR into potentially heads up for cars and just so many different areas. Most people at this point in time would not go out and buy one of the headsets, and so they use their mobile devices like with the Pokemon Go. Do you see that level of AR where people still use their mobile products or iPads or something to use some bit of AR?
Absolutely. If you think of the billions of mobile devices that are out right now, if you have a smartphone, you can start experiencing VR simulations and AR simulations for less than $5 just by purchasing like one of the fold-up cardboard cheesy head mounts that you can get, like Google Cardboard. It's less than $5. You fold it up, a couple pieces of tape, Velcro, and 2 inexpensive lenses, and you're off to the races right there. For school systems that are operating on restricted budgets, Google now has a program. It's called the Explorers program, and they will send in inexpensive head-mounted displays that are based on smartphones, a Wi-Fi hotspot so that each of the mobile devices can access the main simulation inside of the classroom. And teachers now are able to take, for instance, a classroom of students diving for an hour on the Great Barrier Reef, or if they're wanting to teach them about different types of Greek columns, you can take and fly them around 3D scans of the ruins themselves. Take and point out to the students the differences between the different architectural features and so on, as opposed to just letting them fly around and so on and explore it and all that. You can actually guide their attention, teach them, and they're not ever leaving the classroom. I think it's over 1 million students worldwide have been able to experience this on a regular basis in their classrooms now. Circling back to your original question, yes, I think that mobile device-based VR will be around as long as the technologies are around because it's such an inexpensive way for people to experience these simulations.
Well, I highly recommend everybody interested in augmented reality pick up this book of yours because practical augmented reality, first of all, this book has enormous number of pictures and visual representation, which you just can't get in a online version at the same, but also it is a comprehensive guide. And that's something that if you've read just a few articles on AR, it doesn't cover 1/2 of 1% of what's in this book. So I'm very impressed with what you've produced.
You know, the attempt with the book is zero hype. The technology and its strengths speak for itself. The problems that the technologies can solve, the increased efficiency that these technologies can bring to different application environments. It's not all fun and games. It's not all shoot 'em up games, which understandably, this is where the money in the industry is at right now. And so it's getting a lot of the media coverage. It also represents a huge user base. But beyond the games, there's incredible number of solid application areas. Another great one, Lockheed Martin. Every business unit with Lockheed Martin uses virtual reality to prototype products, whether or not it's something just about the size of a human being to large rockets that they're sending into space. They will take, before they begin final assembly, they will bring in the CAD designs and make sure that everything fits together correctly. Making sure that, for instance, engineers have the ability to get their arm into this tight little space in order to be able to tighten down a bolt. All the way through to where engineers are standing during the assembly process so that they have the most efficient movement of a product across the assembly floor. Astronauts are using VR and AR both to train on the ground before they go to the space station, and they're using it as well on the space station. Yeah, there's good stuff coming.
It certainly is. How do people get in touch with you if they have some more questions? What's the best way to reach out?
The best way to reach out is through the website, which is practicalar.com. And this is a companion website for the book. My complete contact information is available there, and we're happy to entertain any questions whatsoever, or feed the enthusiasm that people have for this field.
Thank you so much for joining me today, Steve.
Again, I thank you so very much for the opportunity.
I want to thank you so much for listening today. If you love this podcast, please do share it with your friends and colleagues, and please leave a review on iTunes, Google Play, or Stitcher, because it makes a difference for circulation. For the show notes and other great info, enter your email into the mailing list at techleaderstoday.com. Thank you.